Beep, beep, beep. I don't know how many people are actually going to show up. I'm just going to...
You're right, it does look very sunny behind me. I wish it actually was. It's been raining. It's just beginning winter here, so the weather's turned this past couple of days.
I'm just going to quit some applications so that I'm a little bit less burdened down. Now, I have another application open right now. Can you still see me?
Yep.
Okay.
Oh, somebody else?
Jeremy.
Hi, Jeremy.
Hi.
Hi. And Rhea Nolan from Montreal. Oh, my annoying cat is asking to come in. Just a second.
Oh, lovely.
Hi, Rhea.
Hi. How are you?
I'm good. How are you?
I'm wolfing down dinner. I'm excited to be here.
Oh, good. Are you in Montreal, Rhea? Right now?
I am right now. I'm on my way to New Brunswick to see my dad and then back up to Toronto late next week.
Oh, nice. Is Star Trek starting up again, or is it on?
It's in production right now. I'm not required for the first 2 episodes, but I'm there as of episode 3, so that's mid-May.
Oh, nice.
Yeah,
And
it's been really.
does it seem like there's a lot on the horizon for you? With is there it seemed to me like there was a lot of Klingon at the start of the first season and then a fair bit near the end. Is it spread out a little bit more this year?
There won't be as much of it. Last year I was also working with Jason Isaacs, so that kept me busy all summer with that, between the Klingon and Jason. But Jason's not on this season.
Right.
I'll be working with Shazad, who's the other English actor who's doing an American accent. But there's minimal Klingon this year. I mean, I don't know if I'm going outside my NDA, but they're not as central a storyline to the thrust of the season. So yeah, we'll see. I mean, the writers' room are still working stuff out, so we'll see how it goes.
Cool.
Yeah.
Hello. Has everybody done Zoom before? Anybody not done Zoom before? We're all old hands at Zooming. Okay, so I think I'm just going to start and people can drop in as they show up. I'm going to use the PowerPoint and jump back and forth a little bit. Now, sometimes if you use a screen sharing, then you don't see me as much, which might be good. I don't know. Can you still see me if I share my screen?
Yes. Oh, well, I can because I've got 2 screens going.
But there's also gallery view, right?
Yeah.
So we're going to today I'm going to try to explain the ideas of harmonics and formants and timbre, which is kind of a singing term. It's a bit of an experiment. I want to start with a bit of a disclaimer in that this is kind of my homework for this webinar that I'm doing with VoiceScienceWorks. They have a crash course on this that's a 4-class session that I'm really enjoying. So if what I'm doing interests you, you might indeed explore what they're doing over there on their website and check out their courses. The homework is to explain these concepts to other people. So if at any time you have a question, please fire away, because I'm probably not explaining it well, and hopefully I will explain it better. So a few givens, right? So voice is vibration. The sound is waves of pressure that travel through the air. So the vocal folds are coming together, and thanks to the Bernoulli effect, they oscillate, they make a wave, and that chops the airstream up into peaks of high pressure with lots of molecules kind of close together, and valleys, places where rarefaction, where the atoms are further apart, and those waves travel through the air, travel across the space to the listener, and that moves their eardrum, and that's how they hear it. That vibration, the movement of the vocal folds, creates a fundamental pitch. That's the pitch we sort of hear. That's the sound that we think, okay, I know you're singing an A. It's 440 hertz. The vibration is happening 440 times a second. That pitch is part of our voices. And for me, for the longest time, that was my anchor. I really thought pitch was it. And I think this course that I'm doing has really shown me sort of levels to the voice, aspects of the voice that I had looked at on paper, but I couldn't hear them, and it wasn't expressed to me in a way that made a lot of sense. So this is a little video. You can see that wave going, and the wave is kind of a combination of two sides of a wave. If it's a closed thing, the wave is traveling down the tube, the closed tube of the vocal tract, and it creates highs and lows of pressure that go back and forth. Low pressure, high pressure, low pressure, high pressure. If I go on to the next slide, that air above the vocal folds resonates. Now, if you think of air as a chamber, here's a water bottle. The space above the water is a chamber, and if I blow across here, that'll create a whistle sound, and the space of the air will resonate. So that pitch, a small amount of air, higher pitch. Drink some water. The space gets bigger, the pitch goes lower. So when we talk about the vocal tract, from our vocal folds to our lips, that length of that tube, it's not a lot longer than this water bottle, really. And that space is going to resonate in association with the vibration of the vocal folds. So that space creates a sound of its own that is amplifying the sound of the vocal folds. And so we get a series of harmonics. Harmonics are other vibrations, other cycling at different speeds. They are peaks of energy at regular intervals. So if we go back to this video, we have that's the simple one, going up and down. And then if we go to the twice that, it goes twice as fast, and we get a peak and another peak and a valley in between where there is less energy. Yeah, it's at 0. It's not negative, and it's not positive. If we go on to the next slide, we can see the molecules. Rather than a wave or a skipping rope, we can see the molecules kind of coming together, bunching together, and spreading out. Yeah, so that different areas are sort of thickening up. The molecules are thickening up, and then they're spreading out. So if you watch the center part here, they're kind of bunching together, and now they're thinning out here. So this has 2 poles here, one here and one here. Yeah? And then here's that with the skipping rope animation. Was that a question, Ria?
It was. I'm just wondering, is there, like, just so I'm tracking as closely as I can, the blue wave and the orange wave represent different frequencies at the base of the vocal, like that the vocalis is producing, or performance of the base frequency, or what are they?
To be honest, I'm still struggling to understand this animation because they work together to create the peak and valley.
Right.
And I think they're the different, the vocal folds. Movement. And they together sort of, they're you know, we think of the vocal folds kind of doing this side by side.
Like this slapping stuff,
yes,
yeah.
But they're not actually slapping, right? They're chopping up the air.
Right.
So, this way and this way and this way, right? 3 all at once. Hello, Biddy Ann. Welcome. Okay, so I'm going to go on if I can. So that. I think we've seen that one animate, right? So we get this, the green line is sort of the addition of the various waves together so that we get a super peak and a node that's simplified. Hopefully.
Are those 2 harmonics?
These are variations of the first wave that I showed. So when we start with 1, there's a simple wave, and a harmonic is going to be, that's twice, and that's 3. Okay, so each one doubles, triples. It's like adding. So let's see if my next slide should explain it. If the vocal folds vibrate at 100 hertz, so say that's 100 hertz. I don't know if it is, but it's probably close. My vocal folds are vibrating 100 times a second, but the channel of air above my vocal folds is also vibrating at 200 hertz and at 300 hertz and at 400 hertz and up and up and up and up into the 2,000, 3,000 range. So there's a lot of information there that creates a complex tone altogether. So me telling you that, sure, you should believe me. But I'm going to go into the software now, the VoceVista software, which I don't know whether you've heard of it before. I've heard of it before. But it has the ability to, I'm not sure how I switch. How do I switch applications? Can't get my cursor back. This is not working. I'm sorry, folks. For some reason, I can't. I can't stop my PowerPoint presentation. I'm just going to have to go to the end of it so I can get my cursor back. Okay, here we go. So, can you all see VoceVista now? This is
No.
are you still seeing the keynote?
We're seeing predict formants for vowel shapes.
Oh, okay.
It's like your last page or something.
Mm-hmm. Yes.
When you click on Voca,
Can you see it now?
Yeah, now we see an actual oscilloscope, or like a scan of.
Yes. Okay, good. Thank you. I'm learning as I go how to do this. This is the application VoceVista. And let me just orient you to things that you're seeing on this screen. So here, this area with the blues and the yellows and oranges, that is a spectrogram, and it's showing a logarithmic scale of frequencies. So low frequencies are at the bottom of the screen, high frequencies are at the top, and logarithmic, you can see how 200, 300, 400, they get closer together as we get to 1,000. It continues to get closer together, and that allows us to put things that would normally be quite far apart closer together, so they appear like they're in an even pattern, but actually they're getting further and further apart. They have mapped the frequencies onto a piano, so that helps, I think, for many people to conceptualize where the quote-unquote pitch of the various sounds are in the spectrogram to a piano and to a staff, a musical staff. So I find that useful, and I can grab on this and move it if I want to show lower parts of the spectrum. I can do that. If I need to pull down, I can do that as well. So I want to just play this audio for you to begin with. Anybody guess what this is the sound of? There's no way of knowing.
Notes on the piano?
No. Let's have a listen.
that's a wave. It sounds.
Did you hear that? Hopefully you heard it.
It's a cow!
It's a cow. Yep.
Yay!
So just to prove to you that we can do this not just with our own voices, but with even a cow's voice, I'm going to come in here and select a little portion of the sound. Maybe I'll do it up here. Select that and then zoom in. So this is just a little portion of the sound, and let's see if I can get it to loop over and over. Oh, no, I did it wrong. Can you hear that? So it's just playing a part of the cow mooing. And the fundamental frequency of the cow is right down here. You can see this band here. This is the cow's mooing. And the one thing that Voce, so it's mooing at about 130 hertz. One of the great things about this application is that I can make a little switch and choose a portion of the sound profile. I'm just picking one of the harmonics, and we can just listen to that fundamental frequency. So I'm going to turn the volume of that up a bit so that it's more audible. Can you hear it at all? It's very quiet. Yeah. So now we're going to grab this and go up and hear the other sounds. I'm going to keep it going. You hear how it's an octave above?
Yep.
The next.
Yeah.
Oh, it's so quiet.
Got it.
Yeah. And those are the harmonics that
Those
are like
the harmonics.
And they're like a subset of the bass frequency that the cow.
That's right. That the vocal tract of the cow is resonating along with the simple vibration of its vocal folds as it goes up. And
get this, the whole
pattern
thing
is very predictable. So it's the first one is an octave above. So that's called the first harmonic is the fundamental frequency. The second harmonic is an octave above that. Then you have a fifth above that, the next octave, then a third, a fifth, a seventh, the octave. So they get closer and closer together as they go up. And then it's like note, 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 note. And you can hear those overtones as I drag them. Yeah.
Oh, it makes a beautiful progression just to listen to it in a separate way. That's beautiful.
And now if we play it and then slowly drag all of them back in, you'll hear the chord of it, if you will. Can you believe that's a cow?
Unbelievably beautiful.
Yeah, that's at the heart of a cow mooing. Now, just so you don't think that we can only do that with a cow, we're going to listen to
a lawnmower.
A lawnmower. Okay. So I'm going to grab a portion of the lawnmower. There's our lawnmower. Now there's a lot of sounds there, and you know, a lawnmower is chopping up the speed. The loudest sound that we can see here is probably this band around 200 cycles per second. Now, probably the fundamental is this one here. It's probably rotating around 90 times per second, the blade. So I'm going to isolate the frequency, just a smaller patch of it, and I'm going to drag this down to our, you'll probably not be able to hear it. It's not very red, so it's not very loud. So I'm going to amplify that a little bit. Can you hear it at all? Sort of a brushy sound. Shh. And then I'll slowly go up. Yes, so you can hear there are bands, but because it's not a tube the way like a vocal tract is, or a musical instrument, you know, a reed instrument might be. There aren't even overtones. It's much more chaotic. So there are overtones there, but harder to hear. Okay, so I don't want to spend a lot of time on that. And so,
May I ask a question?
Yes, please, Betty.
Before you said they went from basic pitch to, was it to an octave and then thirds and then fifths and then sevenths?
So it's,
or is
the first one is octave, fifth,
right,
octave. So the first jump is an octave. The second jump is a fifth to the octave. The third,
right.
in the third octave, it's like a major seventh chord. So third, fifth, seventh octave. Then it's tone, 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 tone and a half, something like that. I don't have it all memorized beyond there, but
that's great. That's all I need to know.
It's a very familiar thing. And if you search for what the musical notes of an overtone scale would be, you would find that.
Right. All right. Thank you.
Okay, so I'm going to make a new one.
I just want to say, as you're doing that, just how helpful these visuals are to perceive what we're hearing, and how moving it is that sound naturally creates chords that are moving, that are emotionally, that reach us emotionally. It's really beautiful stuff.
Yeah, I think, you know, that's part of what we perceive as beautiful, is something that fits within the sort of natural order. So I'm just going to make a vowel sound here. I'm just going to record an ah. I'm just going to play around for a bit. So ah. Okay, so I'm going to go a little bit higher. Ah. Pretty flat tone there. Yeah. So you can. I'm just going to grab a little bit of that, like that. And I'm going to zoom in on that, so you can see there. I'm just going to adjust this so it's a little bit more contrasty. You can see the various overtones, harmonic. Yeah. And I'm just going to drag that down a little bit.
Are they also called overtones, Eric?
Overtones is another word for harmonic, yes. So I'm going to make a little filter here, and you should be able to hear my harmonics of my ah. I'm just going to turn that up a little bit. So that's the fundamental frequency that I was speaking at. And as I go up, there's the octave, fifth, octave, third, fifth, seventh, octave. Now I have to make it a little closer so that I'm only getting one at a time. I'll turn it up a little bit higher so you can hear it. Yes, so you get the idea, I think, of how that works. Now, as a guy, my voice is lower. If I have a higher voice making the sound, then it will change the nature of the formants. So I'm going to record again, and I'm going to use my falsetto, and I don't have a very high falsetto, but I'll move up into a higher range, and hopefully you can see how the formants change their look as I go higher. So starting nice and low, switching to falsetto, yeah, it gets breathier and breathier. Now, if I can drag it back, how do I do that? No, not like that. Just a second. Let me get rid of that filter. So if I go across, you can see how many overtones are there. And as I go up, they spread out. Do you see how they're spreading out? Yeah, they're much further apart here than when I was down here. And you have to remember, this is a logarithmic scale, right? That the distance between here and here is the same distance as from here to the bottom of the screen, right? So they are getting further and further apart. So when you get up into very high pitches, I can't go very high, but the top of a woman's range, for instance, these lines would be, right, so we'd be talking sort of up in this area, that would be the fundamental, and there would be very few overtones above it. So what this means is that we often associate a lower voice with a richer quality, and that richness, part of that richness is more information because there's more harmonics and more sound there. It's more of a chord. You see how dense this is here and how loose this is here. There's less energy and less, the energy is more packed into the bars that are further apart, whereas here, the energy is spread across the range. And that's part of what makes lower voices sound richer and higher voices sound brighter, thinner, in those kinds of ways. So I now, let's see if I can switch back to my PowerPoint. And I was here. So the vocal tract isn't just a tube, it's a tube with a variety of shapes to it, right? That it starts quite thick around the pharynx. It narrows where the pharynx meets the back of the tongue. The dome of the roof of the mouth is a little bit wider. The teeth tend to narrow it. The lips change the shape. So there are kind of wide, narrow aspects to it. And these different areas act as a filter. And so they enhance some parts of the overtones and they mute other ones. So some harmonics are brighter and some are made more quiet. Now we talked about the space of the water bottle. And I think it's helpful to think about how the space big space means low pitch. Small space means high pitch. And that will help us to conceptualize things about these enhancements that come from the shape of the human vocal tract. So they've taken that, this comes directly from the website of the VoiceScienceWorks people. And they've taken the classic cross-section of the head, and they've put two water bottles in the vocal tract. One essentially in the throat, and another one to coincide with the space in the mouth. And so these two chambers resonate independently. And because of the nature of the tongue, we can make the size of the throat chamber and the size of the mouth chamber different sizes independently, so that there is a connection with this enhancement of the harmonics, or diminishment, if you will, with the first chamber affects the lower part of the harmonics, and the second chamber, the mouth, that affects the second enhancement of the harmonics. So
that's what your two waves were, probably.
No, those waves are the harmonics. We have to separate the harmonics from the formants.
From the bass frequencies.
No, the
or
bass.
Maybe I'm all confused here.
Yes, this is a third thing. So we have the fundamental frequency, we have the harmonics, and now we have the enhancement of that. Right. So let me go back into VoceVista for a minute. I've lost my cursor again. Okay, there we go. New share. Back to VoceVista. You seeing VoceVista again?
Yep.
Okay, so I'm now going to do some vocal fry for you. Let me come in here, select all, delete. No, that doesn't do it. I'll just come here and start a new one. Okay. So I'm going to record some glottal fry. You can see that glottal fry kind of fills a lot of noise. Get a lot of noise, but there is still some harmonics in it. I'm just going to move that up a bit because it's so low. Now I'm going to change the vowel shape. And we'll see if we can see the enhancement that comes from the vowel shapes changing. You see those lines? The harmonics remain there, but these harmonics are enhanced by different parts of the vocal tract. You can see down here, the bottom frequency, the fundamental frequency, is pretty much unaffected. But the harmonics higher up are affected by the shaping of the vocal tract. And this is the first format here. And this is the second format changing shape. So why do they change and how do they change? Well, let's come in to this area here and figure out what vowel that is. So that's an ah. When I'm making an ah, my mouth is nice and open and my tongue position is down and back. So if we think of our water bottle metaphor for the mouth, with the mouth open and the tongue down and back, is the chamber in the throat bigger or smaller? It's smaller, isn't it? Right? And with the tongue back, the chamber in my mouth is bigger. With it getting smaller, the pitch of this format goes up. It rises up. With the space in the mouth getting larger, the pitch of this format lowers. So it's coming down while the first format is coming up, and they meet for ah. Now here, they lowered. So if this is lowering, that means that the space is getting bigger in my throat. And this space is lowering. That means the space in the front of the mouth is also getting bigger. If this is big and this is big, what vowel could I be making? Any guesses?
I guess ooh.
You guess ooh. Let's see if you're right. Select it, play it. It's very low, so ooh. Yes, it's ooh. Yeah. Yeah, let's come in here. Any guesses? This has gone up, so the space in the front of the mouth is very small. And down here, this has gone low, so the space back here is very big.
E.
E.
Yeah.
E. Yes, it's E. Yeah.
When
So
you're saying the space is big at the back, the space of the oral cavity or the pharyngeal cavity?
the pharyngeal cavity. Now, when I say the pharyngeal cavity also includes the mouth. So the first chamber is really from the vocal folds all the way to the lips,
All the way up.
whereas the second
Right.
one is sort of from your tonsils to your lips.
Right, right. So that's what I'd call oral because it's all like this space.
Yeah.
Maybe I'm being too
Yeah,
choppy.
it's just that the pharyngeal is really pharyngeal plus oral. It's a
Okay.
double, a double.
Another question.
Great.
Doesn't the pharyngeal space go all the way up to behind the nose?
It does. It is not just a simple tube. It includes, and depending on how closed your vocal folds are, there's always a little. If you look at an MRI shape of the vocal tract, there's always a little bump before the soft palate. I recognize now that I skipped a step of something that I wanted to do. And so, how am I doing here? Not too bad. So I think people get the idea of the water bottles and how the spaces move the formants. So the formants are not the harmonics, they are enhancements of the harmonics. And we can see them as these extra bright areas within the banding that is associated with the harmonics. The harmonics are essentially staying where they are, but they are made more energized in some areas and de-energized in other areas. So you can see in this area, it's almost completely gone. It's completely blocked out. That's like a hole there. Okay, so I'm going to clear this out and do a new thing. And do another ah. Here we go. Ah. Okay. So I'm going to come in here and grab another chunk of this. And I'm just going to move this down a little bit. What we're going to do here is listen to the quality of these various harmonics independently. The benefit of the ah vowel, perhaps ah might even be better than that, is that the formants are very even at this point in the vocal tract. The tongue is sort of in the middle, and so the chambers are kind of balanced, and the harmonics are not super enhanced one over the other. If you look on the right side of the screen, you can see there is kind of a dip here around the 2000 range, and there's this bright area between the 2000 and the 4000 range. That's part of the ping of my voice, but it's not too imbalanced. So what I'm going to do is do that filtering again. I'm sorry, make sure I'm doing this in the right place. Select a chunk, create a filter, there we go, make it narrower. So what I want you to do is listen to the sound of each of these harmonics, and I'm going to slowly go up the harmonic scale, and I want you to imagine that you were shaping your mouth to match the sound that you hear. And they will sound a bit like sounds you might make with your mouth. Of course, they will go higher and higher as we go up, but see if you can hear something in them. I'm going to get the... Just going to make it a little bit narrower. Can you hear what I'm pointing at? If I go even higher. Do you hear something in there other than just pitch?
I hear E, a lot of E.
A lot of E, particularly when we got to about here. Yeah?
Yes.
And it's sort of a dull E, and as we get up here,
yeah.
It's a bright E. Yeah? Now, what do you hear down here? What vowel does that sound like?
Ooh.
Ooh.
I got ooh.
Ooh, yes? A little bit more of an aw, maybe? Or an O? O. O. Aw. Ah. 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 Eh. E. 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 Yeah, do you hear how that pitch intrinsically has a vowel sound to it? That the sound of oo lives down here below 500 hertz. And then from oo, we slowly work our way up. Oo, o, ah, e. And when we get to about 2000 hertz, we get into the range of dull E, E, and very intense, bright, twangy E once we get higher up.
Does it make sense? I mean, it's fascinating. Does the same happen if the tone is pure, like the string of a piano, for instance, as opposed to the human voice, which is more organic and has, in the movement?
Well,
obviously.
You know what? I have an electric piano here. It's not a real piano, but it's a facsimile of a piano. Let me turn it on and see if I can play a note and record it, and let's do a little experiment. Just hang on a second.
Floyd, I love that chair.
Yeah.
Your chair. Oh no, it's your pigtails I'm seeing.
I'm gonna get them off my face somehow.
They are so cute. I thought you were leaning back in a chair and I was being envious.
Yes.
It sort of looks like a starship, like a captain chair on a starship.
Close as I get to Princess.
Okay. Let's try this out.
It has both harmonics and formants.
It does, so that the sound that we associate with a piano has peaks. You can see on the right side of the screen that there are peaks that are accenting certain aspects of the harmonics. So these peaks are our formants, and these are our harmonics. And maybe we'll hear vowels in them too. So let's give a try to that. This, because it's below 500 hertz should sound like ooh. Let me just grab a little bit of it, so I'm not doing the whole thing. Let's, yeah. Does that sound, can you hear that? Does it sound ooey to you? Let me make it a little louder. Whoop, I'm outside the range. Okay. Does that sound ooey? We're still around 500. The next one should be sort of O, ah, ah, eh, e, e. We're getting up in the range of E. Do you hear? So those harmonics sound like vowels, and it's not a person talking. It's just a noise.
Right. Interesting.
So that aspect of the acoustics. Can you still see the? Can you see my keynote now?
We've got lips, jaw, and larynx.
Good. Okay. Because I've now lost my gallery thing, and so let's see if we can follow through. If the lips round forward, going back to our water bottle chambers of the vocal tract, the lips lengthen both chambers, really, because you're protruding your lips forward, making the vocal tract longer. Lips spreading wide shorten the second chamber, the mouth chamber, and that raises the second format. So if you're doing E, and frequently people move their tongue to make E and then spread their lips to make it even brighter sounding, that's going to shorten the F2 chamber, raising it higher. Dropping your jaw is also going to do that to a certain degree. So you're going to get a brighter sound in a way because you're raising the second format. So if I'm singing ah with my mouth really open, part of the reason to do that is to make a brighter, pingier second format. If I raise my larynx in my throat, that's going to raise the make the first chamber smaller and make that part of my vocal tract smaller, so making the first format higher. And if I pull my larynx down, like a yawny kind of way, that's going to lower my first format. So it's not just lips or tongue. Your larynx can have an effect on it as well. One thing that I read about was that soft palate lift, which is often part of a lot of people's vocal training, to lift, to make space, that for some people may lift their larynx. If you think of a yawn, typically that comes with pulling the larynx down. So a yawn is going to get space in the mouth and space in the pharynx, and so you're going to get lowering of both F1 and F2 in that case. So if we have F1 lowering and F2 raising on E, F1 raising on oo and lowering, F2 lowering on oo, can we predict, is it possible, what vowel would we have if we had a larger F1 and a higher F2? Is it possible? Anybody?
Sounds like the answer should be yes. I'm just not sure that I'm going to.
Yeah, the answer is actually no. They can't both be high at the same time.
Oh.
Yeah, because to have both chambers large at the same time would mean to have your tongue back and front at the same point. At the same time. And so you can't make that happen. So to make space as large as possible in the back and as large as possible in the front, they sort of neutralize each other, and so you get kind of medium from both, and that's
Okay.
your kind of range. So that's all the stuff I have tonight. Those are the concepts. And
Can I ask you a couple of questions?
please do. That's what we're here for. I'm going to figure if I can stop sharing. Can you still see the screen sharing, or is it just? Is it
yes,
just
I
me?
can.
How can I get it to stop screen sharing?
No,
Oh, there.
haven't
Stop
gotten
screen sharing.
just me yet.
There we go.
There
Now
you
it's just
are.
us.
The questions I have are, when people are trained to sing Broadway,
Yes.
they're trained to lower their larynx.
And what's
So
that going to
they
do?
It gives them a larger formant 1 space,
Right.
but they'll also have a large formant 2 space. So the two of them go together in order to make that bright Broadway sound.
Yeah. So I think the quality that often we think of as legit or classical voice has an aspect to it that people hear as a dark tone, right? Enhancing the darkness. So that there is a lot of space here, but there's perhaps less space in the oral tract, right? I think that's how it goes. To be honest with you, I haven't got to that part in the course. So.
I'm so sorry. I'm so sorry. I live with a musician.
Yes. Yes.
And I know a lot of singers and a lot of opera singers. So this is the reason I'm asking the questions. Opera singers also make sure their first formant is their second formant is very, their oral cavity. The second formant is very open.
Very open, which is going to make it the second formant higher, right?
Yes. Yes.
Is that right?
Yes.
Second formant, no, because their mouth is so open, it shortens the vocal tract, so it makes it smaller. Yes, so second formant is generally higher.
Yes. Yes. So if you're getting sopranos or lyric sopranos, you're getting, but they are working in almost a female falsetto.
Right. And so as they get higher and higher, particularly the sopranos working higher and higher, they're working to a kind of a disadvantage in terms of the formants. The formants exist based on the size of the tube. There's only so far you can go with that. And at a certain point, the pitch of the note, the fundamental frequency, is actually rising above the pitch of the vowel. And so, as you know, we get this vowel transformation thing that happens for sopranos, that as they get higher and higher, they no longer sound like they're singing the vowel they intend to sing, regardless of what they do with their mouth, right? They can be making the most ooey, right, which is the lowest vowel of them all. They can make the biggest ooh sound possible. Doesn't really matter. The sound that's coming out is an ah. And so you can get recordings of singers going ooh and keeping their mouth in an ooh shape, and then get them to do e and go up, and then you compare the high pitches and they're exactly the same vowel, because you can't make vowel distinction at that pitch. That's a difficult concept to understand, but really the vowels live within a certain pitch range of the harmonics, and if your voice is above that, then there's not much you can do about it.
Right. So when we're talking about a lyric soprano who's way up there,
yes,
like
coloratura.
Coloratura, yes. Well, it's coloratura, isn't it? And then lyric and then dramatic. Up all the way in the Mickey Mouse, what I refer to as the Mickey Mouse range. That then becomes pure pitch.
Well, it's never going to be pure pitch. There will always be harmonics over top of it, right? But that those harmonics are very far apart from one another. And so it's closer to a pure pitch. It's, you know, it's not going to be just merely a sine wave, right? That sort of ooh sound that you get from a computer or an oscilloscope making a pure pitch. But it's much closer to that than, say, a baritone in the middle of his range. That's going to be a very rich, resonant sound with many, many, many harmonics, all very close together.
Right. Okay. Thank you for that clarification. I appreciate it.
My pleasure. Any other questions?
Eric, I've got a couple of questions. If
Please.
You can hear me. The first was, I was a little bit puzzled that on the slide that you had about jaw opening. Sorry, I can't remember which was moving in which direction.
Yeah, and I have to say, they asked this question in the webinar I participated in this week, and I answered confidently, when the jaw opens, then clearly it must do this, and I completely got it backwards. That as the jaw opens, the mouth opens, and as the mouth opens, it actually makes more of the oral cavity part of the outside world. And so it's making that front chamber smaller. And so that's going to raise the second format, opening the mouth. Yeah. Now we associate opening with the mouth with things like ah, right? Open your mouth and say ah, which is pulling the tongue back. But if you think of ah, a front vowel, ah, then the jaw is actually enhancing that second format change. So which for a certain degree, I think that some people, as they're trying to make their ah more distinct from things like eh, they actually go ah as opposed to ah. That tends to move it into the ah range, closer to the back vowel ah. So jaw movement ultimately makes the volume bigger this way, but it shortens it. And it appears to me that seems to have a bigger effect than just the larger volume. It's shortening it as it's doing it.
Somehow, if it was possible to do it, isolating, opening the jaw only would result in like a brighter sound, like a higher.
Yeah. So particularly, I think you're going to see it in people singing very high. So I think of someone like, Whitney Houston singing super high notes. It's like she unhinges her jaw so that opens that space up and makes that second format brighter. And you'll often see that in it really doesn't matter whether it's opera or contemporary music. People kind of unhinge their jaw to get that big bright sound. So like an e, they're not going e with their mouth shut, opening it up to brighten those overtones. One thing we didn't talk about is a thing called the singer's format. It's often touted as that sort of bright, pingy quality that allows an opera singer's voice to carry over an orchestra. Johann Sundberg is probably the most famous for popularizing this concept. If we were to look at, if I go back to my VoceVista, I don't know whether, yeah.
We got it.
This is still the piano, so I would have to go back to, making a vowel sound. Let's just do that. So if I'm going, you can see that, you can see the vibrato, which is, I have always thought of vibrato as kind of like a loud softness difference, but really it's pitch difference. You can see the wobbles of the pitch. Just get rid of this filter. You can see in around this area here, this bright area, that brightness is associated with the overtone. The other thing I didn't show you that VoceVista can do, where is it? View, is to show a vowel chart. Now this is an international vowel chart. Oh goodness, what have I done? Let me do that again. Okay, there. It is a, if I click on a vowel, so there's an E, it's going to show you where the first and second formant would be for an E. So if I keep those bars there and I vocalize E, I'm going to move the vowel chart over a little bit. Oh, it keeps resizing in a way that I don't want it to. No, don't do that. It's not letting me. No. I don't get it. I don't get it. I'm going to change this. Sorry about this, folks. I'm learning as we go.
You're so much more willing to play with things than I would be. I would be panicking about now.
Where did it go? There it is. E. Okay, but it's not showing anything. Display, average pitch. E. It's not doing it, though. E. Yeah, I'm going to turn off display average. Oh, stop it. Thanks for your patience, everyone.
Oh, no problem, Eric. It's kind of fun to see it all in action.
Yeah.
So if I'm trying to do E, you can see the well, maybe if I move this back here. Oh, stop it. E, I'm kind of getting the format where E, where the chart says they should be. I do E, I do So the chart says it's one thing. Mine doesn't quite match. Yeah, that it gives you sort of an idea of where to look. It seems like I do that one pretty well. Does that make sense to people? That's a helpful aspect of the tool, so that you can see different vowels mapped out based on values that, you know, an external source has identified that these are sort of international values for various vowels. So if you wanted to learn where those formats were, this would be a good tool to do so kind of in real time, to play around with VoceVista and set those vowels up. Now, there's a free version, of kind of an overtone tool, and then there's the VoceVista cheap version, which is like $70, and then there's the pro version, which is what I'm using, which is in the realm of something like $300. So my university paid for this, so I you know, spend when it's the university's money. I have no problem spending, but I understand that, you know, some people are on a budget, so there are cheap and even free versions. If you search for VoceVista, that'll direct you to that. I think the overtone analyzer is the cheap version of it. Any final questions before I wrap it up?
Have they mentioned at all anything to do with R. Am I right in thinking
R.
that R has something to do with the third formant?
Yes. Yeah, I have done a fair bit of study on R myself, and you're right, third formant is a primary part of that. So see if we can get it to do that. I'm not sure how I get rid of those lines. Doesn't matter. So if I do you can see that that third formant dips. It's being pulled down. If you add a little bit of lip rounding to it, it enhances it even further. And so that's part of why many people say ra, ra, ra with lip rounding, is to enhance that dip of the third formant. So that's a big aspect of the third.
The third formant is the
Typically
larynx?
it is the curling of the tongue. So it creates kind of like a little pocket. Yeah. Now, it's possible to also create it with bunching of the tongue, which is kind of creating a flatness in the narrowing of that oral chamber. So I'm see if I can do that. I'm not a very good tongue buncher, unfortunately. So curling is bunching is yeah, I'm not very good at that. You'll notice that I tend to lip round more when I do bunching, and bunchers typically are significant lip rounders because it helps to make that but you can see how it's pulling it down, bringing the back of the tongue into that velar narrowing.
Now,
yeah,
let me ask you one more question,
sure,
Eric.
please.
You use this for research. Do you use it for teaching?
You know, I'm just learning. I'm just getting used to it. And my hope is that I'll be able to use it for teaching. Mostly, I think it'll be helpful as I explore the concept of enhanced resonance and vocal qualities. So I'm looking forward to, you know, exploring what does, you know, a nasal quality do to your voice. A denasal quality, what does that do to your voice? A breathy quality to your voice, what does that do? I'm not really on the mic, so you don't really hear it. You know, a glottal fry, so that people are getting falsetto, how that affects it. At the moment, what I see is just chaos. And so I don't have the skills yet to be able to interpret that well for students. So my hope is learning to use the tool effectively for that. I think singing is greatly aided by this tool because you can tune in specific vowels with it. So, you know, like if you're singing E and you're trying to get a darker tone, that idea of like adding a bit of ooh to your E, that's going to be an easy concept to teach. If you're trying to get a brighter, twangier how do you do that without going nasal, for instance? You can do a sustained pitch with singing. How do you speak and allow yourself to speak slowly and find ways of not going into pressed phonation, right? You know, so I think it's going to be an interesting exploration for me to see how this tool can be of help. I'm not convinced that it's the be-all and end-all, but
I didn't mean it that way at all.
No, I certainly don't think that for a speaking voice teacher you can use it frequently. I think it's the kind of thing where you're going to pull it out and use it for a specific example and then put it away. But I do think it can be helpful for research, and also just in my own exploration to play around with things so that I have a better understanding of it. Having tried to explain the idea of formants to people, I've said things like, it's like a chord on the piano, but I didn't really know how it was like a chord on the piano, and I couldn't explain it well. And I think at very least, this has created a much better, an oral sense for myself, an acoustic sense of what are the component parts of a vowel. So that's been helpful.
The pictorial along with it.
Yes.
Really will help people, so they're getting more than one sensory input on it, which is very good.
Yeah.
Very useful in that way. Thank you.
Well, thanks everybody. Thanks for letting me practice with you.
Thank you. Yeah. No, that's great. Well done.
Yeah.
Okay.
For this.
I'm going to turn the recording off. I think I'm doing that. And I will end the meeting. Thanks, everybody. And, I think they'll give me homework next week, too. So I might be doing another one of these. So
Okay.
Thanks for your patience.
We'll learn with you. We're more than glad to learn with you, Eric.
Okay.
Thank you so much, Eric. Yeah,
Okay.
it was really
Thank
great.
you.
All the
Thank
best,
you.
everybody. Good night.
Good
Or good
night.
afternoon.
Bye-bye.
Good morning.